class, Amundos. Yes, Amundos. Today we are going to talk about fractions and adding them with uncommon denominators. Mirror my actions. A fraction is a part of a whole. The bottom number, the denominator, tells us how many pieces we need to make one whole thing. The top number, the numerator, tells us how many of those pieces we have. Okay? And we've been talking about this idea of adding and subtracting fractions with unlike denominators. And really what we need is just a lot of practice. And the thing, I know this is cumbersome, you guys. I know it's cumbersome, right? I know it's hard. But practice will make you better at it. I want you to get this down because when we come back from Christmas, we are going to be doing the whole deal where we even reduce the fractions down to simplest form. If you don't have this, you're not going to get that, okay? Please practice these. We're going to take a look at one or maybe even two problems today. We're going to look at 14/5 minus 4/3 first. 14/5 minus 4/3. Minus 4/3. Now, remember when we add and subtract fractions, we need a common denominator because whatever that denominator is, that's what it's going to be in your final answer. So we've got to get the denominator or the bottom numbers to be the same. And we do that using factors, right? So, I usually start with my smallest factor to see if I hit the larger denominator in the list of factors. So let's do our factors of 3. 3 times 1 is 3. 3 times 2 is 6. Well, we didn't hit it, did we? We went past it. So we're just going to continue and I go about 5. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. Now I'm going to go over to my 5, and I'm going to do factors of 5, and hopefully I'll hit one of these numbers, okay? Hopefully they'll be the same. So 5 times 1 is 5. 5 times 2 is 10. Do I have a 10 over here? Do I have a 5 over here? No. 5 times 3 is 15. Do I have a 15 over here? Yes, I do. Okay, so 15 is going to be my denominator when I rewrite the problem. So I'm going to write this problem over again, and we know that our denominators are both going to be 15. Now, the simple rule for this is whatever you do to the bottom number, you must also do to the top number to get an equivalent fraction. So what did I multiply 5 by to get 15? Times 1, times 2, times 3, right? So I multiplied 5 times 3 to get 15. Now I'm going to multiply 14 times 3 to get a number. And it's going to be 42. But you could do it this way. 14 times 3, let's say I don't know, right? So I start at the 3. 3 times 4 is 12. Carry my 1. 3 times 1 is 3. Plus 1 is 4. So I'm going to get an answer of 42/15 minus, well, we don't know yet. What did I do to this 3? What did I multiply 3 by to get 15? Well, this is times 1, times 2, times 3, times 4, and times 5. I multiplied the 3 times 5 to get 15. So I also must multiply the 4 times 5, and 4 times 5 is 20. Right? Now in my answer, the denominator is going to remain the same. It's going to be 15. Okay, because when we add and subtract fractions, the denominator or the bottom number stays the same. Now I'm going to subtract 42 minus 20. It equals 22. Now, many of you might be saying, Mr. B, that's not finished. Mr. B, that's not finished because it's improper. The numerator is larger than the denominator. Remember, this tells us how many pieces it takes to make one whole thing. We're talking about something divided into 15 pieces. This number tells us how many of those pieces we have, right? Well, it takes 15 pieces to make one whole thing, but we've got 22 of those pieces. And since 22 is bigger than 15, we know that that's improper. That fraction is larger than one whole thing. That's going to be after Christmas. We're going to dive into that. We're going to hit that hard. All right, everybody, continue working on your papers. If you need another copy of that paper, send me a message. If you need some help, send me a message. Those of you who have my phone number, text me. I am available to help you. All right, everyone. Have a wonderful day. Thank you. Bye.